What are the values of theta, where negative pi is less than or equal to theta, which is less than or equal to pi, for which 2 cos theta is greater than negative 1, and 2 sine theta is greater than root 3? Pretty brutal problem. Okay, and the way I'm going to start out is I'm going to take one at a time. I'm going to divide 2 from both sides, and that leaves me with a regular cos theta is greater than negative 1 over 2. Now, there's a rule for inequalities that says if you have a cosine of stuff is greater than a number, then what you do is negative cos inverse of that number, so negative 1 over 2, is going to be less than x, which is less than regular cosine's inverse of that number, negative 1 over 2. What that leaves us with is the inverse cosine of 1/2 is regular 2 pi over 3. So this is going to be negative 2 pi over 3 is less than x, which is less than regular 2 pi over 3. Okay? Not fun, but there you have it. The other guy, and of course this is a keyword and, I'm going to divide both sides by 2 again, and that's going to give me sine theta is greater than root 3 over 2. Now there's a rule for sine that says if you have sine of theta is greater than stuff, then you take the inverse sine of that stuff, in our case root 3 over 2. X is going to be in between that and pi minus the inverse sine of that stuff, root 3 over 2. The inverse sine of root 3 over 2 is pi over 3. That's going to be less than pi minus pi over 3. So pi minus 1/3 of a pi is going to be 2/3 of a pi, or 2 pi over 3. Now the key thing here is the fact that this is and. So if I'm thinking inequalities that are separated by the word and, I need to find up where, if I were to graph all of this, where these guys match up. So I'm going to graph the red guy first. I'm going to say 1, 2, 3, you're going to be negative pi. 1, 2, 3, you're going to be regular pi, and I'm splitting this up by thirds because all of these numbers seem to deal with thirds. Similarly, I'm going to graph this guy in blue and do the exact same thing, trying to make the exact same looking picture, splitting it up the exact same way with thirds because thirds seems to be consistent with all of this, negative pi. All right. I care about stuff in between negative 2 pi over 3, so u, and positive 2 pi over 3, so u, shade in everything in between. Don't fill in the circles because it's not or equal to. For blue, however, I only care about stuff in between pi over 3 and 2 pi over 3, shade in everything in between. Since this is an and formula, I only care about where both of my shadings meet, and that happens to be in between here and here. So all of the action happens in between pi over 3 to 2 pi over 3. That's the guy that I want. So doing this whole thing, the magic numbers that I seem to get were 2 pi over 3 and pi over 3. So if you're looking at these guys, the only options that really give you that are D. But this is why it makes sense. Whether it's an easy problem or not, it certainly isn't an easy problem. This is why it makes sense. So the answer for this guy right here is D, baby.